I can show you about the test script. So here I'm running tests for the web. Yep, so it passed. We can run the lint. So again, this is running the company ESLint configuration, and then this will run build. Cool. Yep, it's there, the folder. And then in case we want to publish it, it will be easy as fs scripts deploy CI. But we don't want to do it because like it's a new project and it doesn't have anywhere to deploy. So how this thing works, how do we make it so clients can access to all these functionalities? Some of them are simpler than others. So let's see. So inside the framework, we identify 4 pillars or concepts: templates, commands, modules, and core. So let's start with templates. So templates are the project code base that you want to bootstrap. This is every time you call init, you can specify the name of the template that you want to install inside your computer. In the example of the right, let's say that they have 3 different templates: React, React Redux, and React Apollo. You can easily say yarn fscript init React Redux, and it's going to grab the content of that folder and put it in your computer inside the dependencies. The second point, as I mentioned before, you can have as many as you want, so there's no restriction there. They rely on commands and modules, and we are going to see what are they, and then provide all the basic dependencies. And when I said basic dependencies, is the minimal amount of stuff that you really need in order to work. In the case of the project that I bootstrapped before, as we are using our component library, that dependency is going to be there. But for example, a storybook, when you think of, is not a basic dependency. Basic dependency are stuff that your project really needs in order to work in production. Development dependencies are not, they're not going to be there. So commands. Commands are simple scripts to be executed on the client. They shouldn't require any additional dependency to run, and they have a beginning and an end. So what does it mean when I say they shouldn't require any additional dependencies? So here, commands, they can use any node-specific dependency. Like in case they want to use fs for accessing the file system, path, they can use it, exec, all of process, they can easily use it. Some examples of them are the init script is a great example. We are just using path and fs, and then we are executing some other scripts after that. Translations is just using fetch in order to grab data from an external API. And yeah, it's just that there are some simple scripts that client can run, and they will be really fast normally. This is more or less how they look. You need to provide, so commands are in a specific folder, and then this is the name of my command. So I'm exporting a run function, and in this case is the command of logger. So how do you call the command? You normally will run yarn fscripts and then the name of the command, and here this is going to be the output, logging arguments. And then if I do the same yarn fscript logger 1, 2, it's going to log the arguments and now spreading the others in the console log. Then we go into modules. So modules are self-contained set of commands. What do I mean with that? Inside a module, you can have several scripts of what I showed you before, but they have some other difference, and which some people may think that they are good, but they also have another drawbacks. So the first drawback is they have to be installed in order to be executed, and the main reason is because they can use external dependencies. So for example, I have a module of a storybook. So the module of a storybook needs more dependencies rather than just no dependencies. In this case, a storybook add-ons, a storybook core, React, whatever we're using. So in order to be a script to be executed, you need to have those dependencies installed. So that's why we need to first install the module. Actually, what are we doing when we say we install it? We're copying the content into your folder, into your computer, and then we are installing the dependencies. And the way that they work, and this is one of the main reasons, because I said before that templates, they only need the necessary dependencies. Modules are not going to change your yarn log or your package log JSON. They're not going to change your node modules. They're going to be installed inside a folder in the project, but they're not going to mess up with other versions that you have. So this way, it's very good because it works like plug and play. You run a module, they install, they run, and that's it. And the last characteristic of them is they can have a state. So what that means is you execute a module, right? You install it, it's in your folder, the dependencies are installed, the script has run. Okay, maybe the script does something inside the module, but after it runs, the folder will still be there. So the module itself can change. There is no restriction for that. Actually, we're doing for a few of them. So this is, I would say, it's a perk because it allows you to do some good combinations after. So let's see how they look like. So this is more or less how a module will look like. Inside the folder, one of the things that you need to define is a package.json. In the package.json, you can have the name, the description, the scripts, which are the functionalities that clients can execute from the outside, and then dependencies. The dependencies that obviously the module needs in order to work. So how do you call it? So the same as always, the entry point is yarn scripts, and then this is the name of my module. And if you don't specify anything after the name of the module, it's going to call by default the start script, right? So as I said before, the first thing it's going to do is it's going to copy the module into your project, then install the dependencies, and then run the script that you call. But then the second time, this is not needed anymore, that you are going to copy the module, install the module, and run. So it's just directly, it just directly goes to the run script. So this way of working of this decouple between your project and your functionality, I think is one of the key things of the framework. It gives you a lot of flexibility. The first time you bootstrap the project is super fast. And then you basically install dependencies when you really use them. For example, most of our projects, they depend on dev dependencies at Cypress. Cypress takes a lot of time to install. I don't know if you know about it. So every time you bootstrap a project, you don't install Cypress. You install Cypress once you want to run end-to-end tests. And that changed a lot. That changed a lot. And for teams inside the company, they don't need to be, or they don't have to do React Native. They don't need to install React Native dependencies, for example. So that's one of the keys that I want you to just know. Then the last part is core. So core, I like to call it like as the glue that put everything together, but actually makes more than that. So the main thing is expose the CLI to communicate with the tool. So every time you call yarn scripts, you're actually communicating to core, and then core knows how to execute templates, commands, and modules. And another good thing is totally decoupled from the other, from commands, modules, and templates. And this behaves, this type of architecture is great because we just code core once, and every time we want to extend the functionality of FS scripts, we don't need to go and add a new if. We just add a new template, we just add a new module, we just add a new command. And yeah, it's a very good way of working. And then the last thing is it provides UX for developers. So what do I mean with UX for developers? So for example, in case you're in a module and your module has a state, as I mentioned before, they can have a state. Well, ideally, it can get a little bit messy because you don't know if you're running a module and the output is something that is going to be reproducible, or because you have a dirty state, the output is wrong. So core is going to check if your module is dirty or have a state or not, and then it's up to you to execute the module in this dirty state or regenerate it and run it fresh again. Another thing is checks if you're running the latest version of FS scripts, the same way that Yarn or NPM does. So those little features really improve the way that developers use the tool and communicate with. So the last thing, and for me was something that I recently realized is this concept can be applied to any JS project. And this is the name of my talk. So this concept of templates, modules, and commands, you can apply for web.
Hi everyone, I'm Claudia Bressi and I'm a front-end developer. I work at BYTECONF, where we implement and deliver innovative and cutting-edge solutions for software engineering, data analytics, and DevOps. I started my career on mobile development, then I moved a few years on backend, and in the last years I finally found my way on front-end. I've started coding using vanilla JavaScript coupled with the ancient jQuery, and then in 2018 I discovered React, and I started coding happily with it. In my free time I play electronic keyboard, I go skiing through the Alps, and I experiment recipes in the kitchen. I'm so grateful today to share my talk with you. Thanks a lot to BYTECONF for inviting me here. This talk is about an experiment. It's called React Bandersnatch. So let me first introduce a bit about the meaning to understand why I called it so. Bandersnatch is the name of one of the episodes of Black Mirror Steve series. Not my favorite episode, by the way. And it's made as an interactive film where viewers, so people like you and me, can make decisions for the main character, a young programmer who is writing software for a video game. In the end, the morale seems that even if we have some freedom in choosing something, then if you try to dive deeper and analyze the situation, maybe you will realize that this freedom is a well-designed illusion, and to make a comparison, this sounds quite familiar to the first episode of the trilogy The Matrix. My project is about React, which, as most of you already know, is a good library to build user interfaces. A library and not a framework as Vue or Angular or other frameworks out there. So this project starts with one simple idea. What if React could be one day a framework? Probably React is better designed to be a library, and I do personally prefer it as a library. But what if React could be a real framework? I'm just not saying that frameworks are better than libraries or vice versa. I just believe it depends instead of the context on the project you are working on. But let's see what happens and then measure the results as scientists do in a laboratory. The mouse in the cage this time is React, but we won't hurt anyone, I promise. This is only a conceptual experiment. For this project, I've built some real application using different packages, which are normally available inside one typical front-end framework. After that, I measured some significant web application metrics, and then I've compared the achieved results. But let's now review for a second the concept of framework. A framework is a platform where we can have some ready components, or let's say tools, which can be used to build some software or a user interface without the need to search for other external dependencies. Sometimes there are some reasons about using a framework over a library. You can find a built-in routing solution, state and module management, and even testing tools already available in your platform. You just need to add proper configuration code and you're ready to go and code whatever you want to implement. So, in a few words, why someone should go for a framework? Well, it's so comfortable to have something ready and nothing to choose. But moving on to a strict comparison with libraries. Frameworks are more opinionated and they can give you rules to follow in your code, and they resolve at the same time for you the order of things to be executed behind the scenes. For example, this is the case of lazy loading to deal with modules in a big enterprise web application project. On the other hand, libraries are more minimalistic. They give you only the necessary in order to build your application, and at the same time you have more control and freedom to choose whatever package in the world. But this can lead sometimes to bad code, so it's really important to be careful and follow the best practices when using libraries. Let's then talk a bit more about this project. And this is probably will not have a limited ending, mainly because it could be explored deeper and combined in many possible scenarios. To start with it, I built a very simple web application, and I've implemented a weekly planner. This consists of one component showing the week and one another showing the detail for a specific day. Then we have some buttons to update the UI, for example, for adding events and appointments. And it's important because I can see the state manager implementation in action. Well, as you can see, I'm not a UX expert. I'm just a front-end developer, so this is not the most beautiful UI in the world. Then moving on, I've then defined a couple of constraints to this project, and these are related to the use of some common technologies. In particular, we need to use, of course, React, and I've used the latest available version. Then I've added TypeScript with a version that finally can let us employ the optional chaining. And for styling, I've used only CSS files, so I've included a SES compiler. And by the way, while writing my components, I've styled them using the very useful CSS module syntax. I've then defined a precise set of metrics to measure our experimental framework. First, the bundle size, measured in kilobytes, of course, to understand how much weight we reach with each build. Then we have loading time, which is the amount of time needed to load the HTML code in your application. Scripting time, which is the actual period of time to load the overall JavaScript files. Then we have render time, that is basically the time needed to render the style sheet inside the browser. And the last minor metric is painting time, which measures the time for handling media files as, for example, images, videos, and so on. The package used for this experiment are the ingredients of this project, and I've tried to choose both popular and well-known tools among the React scenario, but at the same time some packages are less famous, but with features that can improve the overall performance on medium-sized projects. So in the next slides we'll see a combination of these ingredients. The first implementation could be considered as a classic way to solve a project in React. It's based on Redux for the state management and Tank as a middleware solution. Then I've used the very well-known React router, and finally the popular Material UI for having some ready-to-use UI components. The second application is more sophisticated and made of Redux combined with Redux Observable package for handling the middleware part. As router, I've then applied a custom router solution to let me play more with React hooks, and as icing on the cake, I've taken the Ant library for building up some UI components. Moving on the third application. For this, I've blended together the MobX state manager with my previous hooks-based custom router, and for the UI, I've used the Ant library. Finally, for the fourth experimental application, I've created a quite simple solution with MobX, Redux for a better organized structure, my hooks-based custom router, and the Material UI for the components. Analyzing then a bit deeper these four implementations, what I found is that Redux as a state manager has a cleaner and better organized structure due to its functional paradigm. And another benefit is the immutable store, which prevents any possible inconsistency when data is updated. On the other hand, MobX allows multiple stores and this could be useful sometimes if you need to reuse some data. Let's say the business logic part of your store in another different but similar application. And that is a case I've met recently with a customer in a real business context. Another advantage of MobX is the benefit of having reactive paradigm, which will take care of the data updates, so you can skip any middleware dependency. Talking about routing, one built-in solution like the React Router DOM package is so easy and smooth to apply in order to set up all the routes we need within our application. However, a custom solution as our hooks-based router solution will let us keep our final bundle artifact lighter than a classic dancer. Moving on the UI side of the framework, Material is a widespread web styling paradigm. Its rules are easy to apply, and the result is clean, tidy, and minimalistic. But from my personal point of view, it's not so good and not so elegant to pollute JavaScript code with CSS syntax, and that's why I prefer to keep things separated. I then searched for another alternative UI library and I found Ant, which is written in TypeScript with predictable static types, and this is a real benefit for my applications. However, Material UI in the end wins because it's lighter than Ant. But both of these packages allow to import only the necessary components you need for your project. So, in the end, it is a matter of taste which library to choose for the UI part. But if you look more at performance, then go for Material. As a final step, after having built our application, it's time to compare the achieved results. For each metric we've previously selected, the values are taken accurately, and in doing this, I've used the performance panel you can easily find inside the useful Chrome developer tools. From the collected results, it's quite significant that the most performant application is built with the lighter bundle size, and in particular when using Redux coupled with Tank, Material and our custom router, then the resulting application has a smaller output artifact and so optimize values for loading, scripting and render times. So in the end, the winner of this specific experiment is application number 4, as you can see from the results. But I guess for bigger projects, the results could indeed vary. Frameworks sometimes offer some useful auxiliary built-in plugins, as for example the CLI, available in some frameworks, to easily use some commands or automate repetitive tasks and so improving developers' life. That's why I've shared here some of my preferred tools available for React environment, which I would probably include in a React ideal framework. First, let me mention the famous React and Redux extension for Chrome, and I found these essentials and useful as the ruler for an architect. Then, another useful plugin is the ESLint, specifically written for React, which make easier to be consistent to the rules you want to keep inside your code. Then, Prettier is another must-have plugin available if you use VS Code, and it helps a lot in getting better formatted code. React Sign, instead, is a Chrome extension which helps a lot in showing a graph and to represent the overall structure in order to analyze your components. Last but not least, I would include the very popular React extension pack, which you can find as a VS Code extension, and it offers a lot of developer automated action as hundreds of code snippets, IntelliSense, and search for files within Node modules. Thanks for your attention. Feel free to leave a comment or contact on my social channels. I wish you to stay safe and keep learning something new every day. Bye!
inside until we can see the world is greater than we ever imagined it could be. Covered in part by shadow and those aspects of ourselves. Until the light of day.
Hi there, my name is Henrique, and today I'm going to show you some tips and tricks for speeding up your Gatsby website. I work at Chaotica, which is an agency focused on building performant websites, and we've been working with Gatsby since 2017. This talk is based on that experience, okay? If anything, reach us on Twitter, specifically me on this handle that you're seeing. So why bother about performance? I'm sure you already do care about it, otherwise you wouldn't be using Gatsby. But maybe you can learn something new, some other reasons. So first, faster sites means better experience, so then users are happier. Happier users are more inclined to buy and engage, so you have higher conversions. Search engines know all that, so you have better SEO as they will boost your site to make users happier. Also, less server work, meaning you send less down the wire and the website is faster. Also means lower costs, lower bandwidth. So yeah, lower bills. Also, these leaner websites, they use less energy, so they are better for the planet. They are more sustainable. And finally, having a fast website means everyone can use it and enjoy your work. So not only people in urban areas with nice connections and great devices, but also people with spotty connections and low-end mobile phones can enjoy your work. So it's more inclusive. All right, so you probably came into Gatsby because it's fast in every way that matters, and it really helps you making your website performant. But I've put this to the test. I ran Lighthouse tests, which Google Lighthouse, if you don't know, it's a tool that tries to estimate your performance of your website and some other stuff, but here we're focused on performance. And I tested all the 920 something websites from the Gatsby showcase, and the results that I came to, although Gatsby is great, it shows that we aren't exactly on a great path. So out of 922 sites tested, the median Lighthouse score was 75, and that's Lighthouse V5. The V6 that is coming in a few months, it's 71. So we're actually decaying in terms of performance over time. And that's mainly due to the impact of JavaScript. I'm going to get into that later, as the Lighthouse score is changing how it's being calculated. Of course, these scores aren't very reliable, don't get fixed on this number, although it does indicate a range of 70 to 80. That's very reliable though. We are gonna get into more concrete data that isn't dependent on Lighthouse specifics. All right, so the goal of this talk is, based on this number, how can we make performance better for every Gatsby site out there? And I draw from some of this knowledge. So first, we can search fonts locally. Many websites can benefit from this. Out of these 922, 35% is actually using Google Fonts directly from their URLs. And this means that they load this nice link in the head of the HTML that points to fonts.googleapis.com or something like that. And then this sends the browser to another link or to another to a style sheet that has a bunch of font face declarations, which in turn sends users to fonts.gstatic.com to get the actual WAF file, the font file. And this adds two new origins that you have connect to, and this adds a lot of wasted time to your performance. So this is an image by Sierra Caramallegos in her post Making Google Fonts Faster. And this illustrates, basically we are going to fonts.googleapis.com and we have to resolve the DNS, get the SSL for that, and then go to fonts.gstatic.com. And this adds a lot of weighted time that your user has extra. And also when we self-host, we reduce that, especially if we inline the font face declarations. We don't even need the separate style sheet anymore. So we're just going straight to our own origin, which is already resolved, to get the font files. And this is significantly faster. We could use a plugin to do that. There is Gatsby plugin prefetch fonts, but this adds an extra build step, and also it hurts client-side caching because it changes hashes every once in a while. So I would follow CS post. It takes around 25 minutes just to digest and implement it. It's very quick. Next up, we have lazy loading wherever possible. So we already use Gatsby image, most of us. Lazy loading is basically when the content shows up in the screen, that's when it's going to actually be downloaded to avoid unnecessary requests if the user never gets there. It also makes the first load faster. So Gatsby image makes it really easy and nice to do. And we are doing great about that. So out of the tested websites, over the median score for off-screen images and responsive images is 100%, meaning more than half of Gatsby websites are actually implementing Gatsby image in a proper way. And the average is like 90%. So most of them are doing this pretty nice. But we aren't doing very well in terms of third-party scripts. So if we take a look at the amount of third-party JavaScript, right now it's 98 kilobytes, the median of JavaScript being downloaded before the user scrolling, before the user interacting with the page. This is actually 31 kilobytes download, just there's a difference there. But the average is 600 kilobytes. So there's a big jump from the median to the average, meaning there are a lot of websites out there that are really doing a bad job at decreasing the amount of third-party JavaScript. Also, the median request count is 2 and the average is 5. So the average Gatsby site is loading 5 third-party scripts and files, which isn't very nice. So how do we solve that? We can lazy load iframes in scripts, for example. So if you have a MailChimp form or a YouTube video that doesn't show up in screen right away, we can lazy load it. How do we do that? For example, a lazy embed that is going to only load an iframe for CodePen or YouTube, for example, when it comes into view. It's very simple. Like we could get a using view hook that when the element is in view, we set the HTML of that element as that code that we are receiving as a prop. If you want to learn more about this using view prop or hook, you can take a look at this screencast that I made. Also, we can go a step further and remove the lazy loaded components from the initial.js bundle. So for example, if we have a HubSpot form that only shows up in the footer as like a contact form or subscribe to the newsletter, and this takes some like HubSpot specific JS code that adds a lot to your bundle, we could lazy load that. So for example, here we would get HubSpot form is a lazy React component with the new suspense API. And then whenever the content is in view, we go in and fetch it with suspense. So this is not going to be included in the initial JS bundle. We are saving some good bytes there, some good kilobytes and potentially megabytes there. We can also rethink analytics by, for example, loading the scripts only after the page is ready. This way we are going to lose some data because users that didn't actually load the page aren't going to be registered, but we're also going to get lower bounce rates due to the better performance. We could do lighter analytics, such as simple analytics that's 4 kilobytes versus Google Analytics 79. And we can also do some server-side analytics, such as Netlify or Cloudflare workers. When to lazy load? Basically, if it's going to be useful for the user only when it shows in screen, and lazy loading it is not going to affect UX, then please lazy load it. But bundle size and request counts, they aren't everything. JavaScript also plays a huge role in performance. And if you want, you can read more about it in the Cost of JavaScript in 2019 article by Adi Osmani and Matthias Bienen. This post really illustrates how low-end devices, they can really suffer from the actual parsing and running of JavaScript, not the actual downloading. So while if you download an image that is like 200 kilobytes it's 200 kilobytes and that's done. There's not much that the browser has to do to actually render that. When you download 200 kilobytes of JavaScript, that actually has to be unzipped, and then it's gonna have to be parsed, transformed into bytecode, and this takes a while. So while Gatsby has great DX, this great DX also can lead us to make poor choices about JavaScript. We can include stuff that we otherwise wouldn't if we had a little bit of friction. So we just want to be more mindful about that. So the median amount of minified JavaScript on load, that's not like after you browse the website, but just on load, is 891 kilobytes. The average is 1.58 megabytes. Of course, the gzip and minzipped is is significantly less, so the users don't download this 1.58 megabytes, but their browser has to process that. So this is significant, and also this reflects in the time to interactive, which on average is 7.1 seconds until users can actually interact with the page, and this is a long time, right? So please do test your website on low-end devices and connections to make sure it's working properly and there is no jank there. So the first thing you can do in terms of JavaScript is switch to Preact. That's really quick. It's gonna take you like 20 minutes. Preact, if you don't know, it's an alternative to React that is just smaller and focused on performance. And it covers 99% of React use cases. And if you can switch to it, you are going to save around, so you're going to go from 121 kilobytes of the baseline for your app to around 10 kilobytes. So this is significant, and trust me, it does reflect in performance. So for example, this website, we went with React from 261 kilobytes of minified JavaScript to 165, and this also had a good impact in our Lighthouse score. I don't have, as the client changed it from a Netlify domain to their own server, so this is like FTP. If I want to update it, I want to FTP. I don't have the history anymore to share the URLs with you for testing, but trust me, it is significant and you should try it. It's going to take about 5 minutes. So how to do it, you can read my blog post on it, or you can go into Gatsby plugin Preact on gatsbyjs.org, or you can follow this Gatsby recipe that just came out last week, and I implemented a simple one for Preact for you. We should also rethink our usage of NPM packages. So for example, Gatsbyjs.org has 97 packages in its package.json. Most of them are probably just developer tools. They are not going to go into the bundle that the client consumes. But the ones that are sent, they are code splitted. So this, I'm not talking that, hey, this is like a huge thing, but this is hard to manage, and each dependency has their own, and this can make it really hard for new people coming into their code and downloading it. So there's a problem there, but that's not the focus here. I just want to show you that actually using other people's code can be worse than doing it yourself at times. So for example, implementing carousels. I don't know if you've been there, but it's terrible. It's boring and it's usually bad for UX. Personally, I try to avoid carousels as much as possible, although they have the use cases. So most people, when they have to implement one, they would reach for a package, search npm, and find React Slick, which is the most popular out there right now. React Slick, the download size of it, like npm install, it's 700 kilobytes, and the bundle size in the end that the browser consumes is 57 kilobytes. This is huge. This is 5.5 times Preact's size for a carousel. So why should you create it from scratch besides the lower performance overhead? Well, you don't have to learn a new API. You don't have to wrangle with CSS to force it to display it like the brand that you want, to follow the actual design. You don't have to debug external code, which can be really hard. And users are going to be happier because the site is going to be faster. And also designers are going to be happier because it's going to be more in tune with their design. So how do you do that? It can take around 25 minutes to do it, if you believe me. You can follow this tutorial that I recorded. Of course, complex carousels, they take longer. They can take a full day, they can take a week. So I'm not saying that everyone should build stuff from scratch, and not every team has this privilege. I just want to show an example where, hey, NPM packages is not the de facto standard. Sometimes you should do it yourself. Also, you should measure CSS and JS impact because it can add a lot of overhead because of how its foundation work. So if we think about regular class names and CSS files, React is going to do all the rendering. So it's going to understand your component tree and spit out the HTML. And then the browser is going to parse that CSS. And that's it. Although there is a lot of steps involved, modern machines don't really have any problem with that. But when you add the extra component-based CSS library, we have an extra step that is like we have to process the CSS strings, inject some theme context, auto prefix, do some component composition, and that takes a while. Again, in modern machines, in desktops, for most use cases, this is not going to be a problem, but still, it's adding some work for the browser. If you want, you should probably look into the React profiler to see what is the actual impact of that, and maybe read through this post by Agelos, okay? So measure its impacts, especially for highly dynamic sections. For example, here this screenshot is from Data Hacker's website that we created a Slack widget in it. So it recreates Slack, and there's like a simulation of a live chat here. And it has over 1,000 nodes of HTML that are dynamically being updated. And that adds a lot of work for the browser. And I was feeling it really janky on the phone. And I profiled it, and I figured this specific section, not the rest of the website, but this specific section, I should ditch styled components in favor of just regular raw CSS. And that's what I did. And the end result was pretty good, although this lighthouse score is a bit misleading because I also switched to Preact. But the idea is that, and it is considerable in terms of the lag that I saw on the mobile phone. It's much better now. Plus, you don't have to ditch CSS and JS. Compiled CSS and JS is a thing, and it's becoming a thing. Basically, we move all that big client work, or most of it, into the server. So that's really nice and gonna really do a lot for performance. The field is also moving fast. We have Stylus v4, which is the basis for emotion and styled components. It just came out this week, like 3 days ago from me recording it. And it's much faster and much smaller. Gatsby is investing in theme UI. There's a brilliant team behind it, so that is going to give us a lot. Styled Components v5 came out early in 2020, and it is significantly faster and smaller. And also we have some smart atomic CSS generation that can even have better performance than native CSS. So yeah, you should take a look at this video that I linked for Facebook's Stylex. That's a very, very nice idea. But the overhead is still there. So behind, well, even though we compile it and we do all that, stuff are still duplicated. So if you look into the index.html file for the site fractalinvestimentos.com.br, it includes the CSS like we would expect because Gatsby pre-rendered it. But if we look into the JS bundle, the same CSS is there. And this specific site, it's very complex in terms of styling. So it's 38.3 kilobytes of CSS. And this is being duplicated. And this highlights Gatsby's biggest bottleneck, which is content duplication. So besides the obvious bundle size problem, we are also forcing users to do the same work that the server already did, right? Just 1 second. And this works for page data, for CSS and JS, and also the actual HTML, which is duplicated between the component template and the final HTML. And this is reflected in the real world. So The Medium page has 114 kilobytes of index.html plus page data.json, and there is always some intersection there. And the average is actually higher. It's 212 kilobytes. Of course, the download is lower, but here we are focused on the work that the browser has to do, not the actual download. And also there's a huge standard deviation, so there are some websites who have it much worse. So please pay attention to that, be a bit more mindful of content duplication. So for example, lazy loading that we introduced before, that means the content won't show up in the HTML because Gatsby, when it's pre-rendering the content, it's not going to pre-render the lazy loaded components because it's only after mount, etc. So it's not going to show up in the final HTML. So we got rid of that duplication. But this, of course, isn't always possible, and you can't do that for the whole website. Otherwise, what's the purpose of pre-rendering? But the Gatsby and React teams, they're working on approaches for partial hydration, meaning we don't have to ship the whole data, we don't have to ship the whole JS, we just have to ship enough for like the dynamic sections. And this is gonna be a huge performance boost for websites, both in terms of download size, but also the overhead of JavaScript. So if you're interested in Gatsby performance, please put some pressure in the community for this to be a reality, all right? So just to recap, first, serve fonts locally. Second, lazy load where possible, especially heavy scripts. Switch to Preact, it takes 5 minutes. Rethink NPM packages wherever possible if you have the possibility. Measure the impact of CSS and JS because it might be hurting your users. And be mindful about content duplication. And in conclusion, performance is much more than bundle size, as you saw. And it can easily overwhelm us, but don't fear because you can take incremental steps for performance and make things better gradually. You don't have to go all in and hey, let's take like 2 months of diving deep in performance and reading performance books. Just go slowly and be mindful about these topics. This is supposed to be an introduction to your performance journey. And it's going to help users, and by helping users, it's going to help the planet, and it's going to help your company or the companies that you work for. So thank you for your time. If you have anything, reach me on Twitter. Feedback is always welcome. I will put a link for a feedback form here in this slide, if you can, because that's my first talk, and hopefully you can help me with that. And have an amazing day. Let's talk about Gatsby performance. Let's do some further benchmarking in the repository, the data that I shared. And yeah, have an amazing, I hope BYTECONF was amazing because that's the last talk. And have a good one. Thank you for your time.
And my